For decades, Pluto existed in the outermost chapter of our solar system as a distant mystery. It was little more than a tiny point of light, so far from Earth that even the most powerful telescopes could reveal almost nothing about its surface. Then, in 1930, astronomer Clyde Tombaugh discovered that faint moving object while carefully comparing photographic plates. The discovery immediately captured the world's imagination. Pluto became the ninth planet, and generations grew up believing that the solar system ended with this tiny frozen world. But for most of that history, we barely knew Pluto at all. Its enormous distance made detailed observations almost impossible. Scientists could estimate its size, orbit, and composition, but the surface remained hidden behind a blur. Many imagined Pluto as little more than a frozen, inactive rock drifting through darkness. That image survived until 2006, when the International Astronomical Union classified Pluto as a dwarf planet. For many people, Pluto suddenly seemed less important. Then came New Horizons. After traveling for more than 9 years, NASA's spacecraft reached Pluto in July 2015. It passed the distant world at tremendous speed, collecting observations that completely transformed our understanding of it. Instead of a dull frozen ball, New Horizons revealed an astonishing landscape. There were enormous mountains made largely of water ice, vast plains covered in nitrogen ice, dark reddish terrain, and a huge bright region resembling a heart. The surface showed evidence of geological activity far more complex than anyone expected from such a small and distant world. Pluto had not simply been sitting frozen and unchanged. It had a history. Its atmosphere was another surprise. Pluto possesses an extremely thin atmosphere dominated by nitrogen, with smaller amounts of methane and carbon monoxide. Sunlight, even at Pluto's immense distance from the Sun, can still trigger chemical reactions high above the surface. Ultraviolet radiation breaks apart methane molecules, allowing their fragments to combine into more complicated hydrocarbons. Eventually, some of these compounds form hazes and settle toward the surface. These materials, called tholins, are believed to contribute to Pluto's reddish and brownish colors. It is an extraordinary chemical cycle occurring in a world where temperatures are low enough for nitrogen and methane to exist as frozen materials. But Pluto's atmosphere is not permanent. Because Pluto has weak gravity, some atmospheric particles can escape into space. Seasonal changes also influence how much nitrogen and other gases remain in the atmosphere at different times. And Pluto does not exist alone. Its largest moon, Charon, is almost half the diameter of Pluto. The two objects are so closely connected gravitationally that they orbit a shared center of mass located outside Pluto itself. This makes the Pluto-Charon system unlike the usual planet and moon arrangement. Even more fascinating, observations indicate that material escaping from Pluto may contribute to the chemistry found on Charon's surface. Charon's poles contain dark reddish deposits. Scientists believe methane transported from Pluto may become trapped there, where sunlight and radiation gradually transform it into more complex organic compounds. In other words, these two distant worlds are chemically connected. Pluto loses material. Charon receives some of it. Radiation changes that material over enormous stretches of time. And the resulting compounds remain frozen on the Moon. But the strangest discoveries may lie beneath Pluto's surface. New Horizons revealed enormous mountains and unusual geological formations that suggest Pluto experienced significant internal activity. Some researchers have even proposed that certain features could represent cryovolcanic structures, formations produced not by molten rock, but by icy material moving from the interior. If that interpretation is correct, Pluto may once have possessed enough internal heat to drive geological processes long after its formation. And that raises an extraordinary possibility. Could something still be hidden beneath Pluto's frozen crust? Could a buried reservoir of liquid or partially liquid water have survived there? The answer remains uncertain. But Pluto has already taught us something important. Distance does not mean simplicity. The smallest world at the edge of the solar system may have a far more complicated history than humanity ever imagined. And our next question is even more fascinating. What could still be happening beneath that frozen surface today? Pluto looks frozen, silent, and almost lifeless. From billions of kilometers away, it appears to be a tiny world trapped in permanent darkness. But beneath that surface, scientists suspect that Pluto may have experienced a surprisingly complicated geological history. One of the biggest clues comes from its unusual mountains and surface formations. Near Pluto's equator lies a remarkable region known as Tartarus Dorsa. It contains enormous blade-like ridges stretching across the landscape. Scientists believe these formations are composed largely of methane ice and may have developed through processes unlike anything commonly seen on Earth. Imagine standing there. The sun would appear extremely small in the sky. The ground would be dominated by frozen nitrogen, methane, and water ice. Above the surface, Pluto's thin atmosphere would create a faint haze. Yet this seemingly lifeless environment would still be changing. Pluto's surface is affected by sunlight, radiation, seasonal cycles, atmospheric transport, and the slow movement of volatile ices. Nitrogen can migrate across the surface, evaporating in one region and freezing in another. Over enormous periods of time, these processes can reshape the landscape. Another mysterious region is Cthulhu Macula, a vast dark area covered with reddish material. Its unusual color is associated with complex organic compounds created when radiation interacts with methane and other molecules. This chemistry does not mean Pluto contains life. But it does demonstrate that complex carbon-based chemistry can occur in extremely cold environments. And then there are Pluto's possible cryovolcanic features. Two enormous formations, Wright Mons and Picard Mons, have been studied as potential evidence of cryovolcanism. Instead of releasing molten rock like volcanoes on Earth, cryovolcanoes could potentially transport mixtures of water, ice, and other volatile materials from the interior toward the surface. If these structures really formed through cryovolcanic activity, Pluto must once have possessed a significant internal energy source. That leads directly to one of the biggest questions about this distant world. Could Pluto have an underground ocean? Scientists have proposed that Pluto may contain a layer of liquid or partially liquid water beneath its icy shell. Such an ocean would be incredibly difficult to detect directly, but geological evidence and models of Pluto's thermal evolution have made the possibility worth investigating. Radioactive elements inside Pluto's rocky interior could generate heat over geological time. That heat might help maintain warmer material deep beneath the surface. However, the existence of a present-day liquid ocean has not been confirmed. This distinction matters. Pluto is fascinating precisely because scientists are still separating what has been observed from what remains possible. The James Webb Space Telescope adds another layer to the investigation. Webb cannot resolve Pluto's surface with the detail achieved by New Horizons, because Pluto is tiny and extremely distant. But Webb can observe infrared signatures and study the dwarf planet's atmosphere and surface composition in ways that complement the earlier spacecraft observations. Together, these instruments provide a more complete picture. New Horizons showed us Pluto's landscapes. Webb helps investigate its chemistry. Future missions could potentially examine its interior. And that is where the story becomes truly exciting. Pluto was once treated as the insignificant world at the edge of the solar system. Today, it is considered one of the most intriguing objects in the outer solar system. It has a complex atmosphere. It has active surface chemistry. It has enormous geological structures. It has a strange relationship with Charon. And it may even preserve clues about an ancient internal ocean. We still do not know exactly how Pluto formed, how its interior evolved, or whether liquid water remains hidden beneath its crust. But perhaps that uncertainty is the most important discovery of all. The farther humanity explores, the more often we discover that supposedly simple worlds are anything but simple. Pluto was never merely a frozen rock at the edge of space. It is a record of the solar system's ancient past, a world shaped by ice, radiation, chemistry, gravity, and time. And somewhere beneath its frozen exterior may be another chapter of that story, still waiting for humanity to uncover it.